Alrighty, so I'm all set up here, so let's go ahead and get started. So this talk is geared specifically towards you guys and getting you access to data so that you can do, we have math and stats, we have econ, we have marketing, we have finance, we have all of these different majors, and you guys are all being trained to do what you're being trained to do, but the question is, can you get to the data? And so I'm doing this talk because I want to make sure that you guys are able to get to the data if that data is in a SQL database. As it commonly is in a lot of commercial environment, SQL databases constitute a large portion of data storage in private companies and also government data storage. So let's go ahead and get started. So the agenda real quick is who this is for and why should you care. Then I'm going to go into some simple databases, and then we'll get into some relational databases. And then lastly, I'll give you a sort of a jumping off where you can go from this presentation. Before I do that though, real quick, CYA, what I'm going to present is what I consider best practices. But you may find other people, I don't know if there's any CS majors in here, but there are some competing ideas on what the best practices are. I'm going to give you what I consider my best practices, but you certainly can't go wrong. And then there's also going to be some SQL inconsistencies. SQL is a loose standard at best. So we have all of these different implementations of SQL, and they all follow a general SQL syntax, but they all kind of take license to tweak things in their own ways. And I'll touch on that just a little bit. So why should you care? Since you're here, you may have already had a general idea of why you might care, but I have a little comic here that might illustrate it a little bit. Basically, it's about getting to the data. I think he might have had a little bit of writer's block when he came up with this comic. But in any case, so it's about improving your competitiveness, self-sufficiency. If you're waiting for somebody to go and get the data for you, or waiting for IT to build you an interface that'll get you that data, that can slow you down. So if you're able to actually reach out and touch the data yourself, you're more self-sufficient. You can get where you need to go yourself. Also, I think that just by actually getting your hands in the data and kind of mulling around in the database, it gives you a better understanding of the processes that are being stored. You look at all of these different tables and you can kind of get an idea, okay, this is being stored this way, and maybe because of this, so maybe my point of sale system, I can kind of see, okay, these are the records that every time someone does a point of sale, these are the records that get stored. It gives you a little bit better understanding and maybe helps you interpret the data a little better as well. Better data organization, and this is something that I deal with daily, which is oftentimes what you will have is what's already there. But as you've been working there for a while and decisions start to come up and we have new data to store, actually having your hands on the data will give you a better understanding of how you might store data better in the future. So let's go ahead and take a look at what is a database. And this is a map of a database. And it just kind of gives you an idea, a visual representation of how data is stored. And we'll come back to another one of those to look at a little bit more closely. So a database is a collection of data typically organized to model relevant aspects of reality. And what this is really saying is we model databases around the things that we care about. We want to store grades. We want to store weather information, health, reports, all these different things. So we'll model a database around some activity that we use or something that we're doing. So it mimics that activity, basically. And so we have lots of implementations of SQL, like I was saying earlier. These are just a few. MySQL is a popular one. Oracle is probably one of the largest enterprise. Postgres has had a lot more, has been getting a lot of traction. But then you also have people like IBM, and Microsoft has their Access database, which some people like. I don't know how wide it's used in large mission critical data storage, but those options are all there as well, and they all have they're all an implementation of SQL. So if you understand SQL, or if you understand the basics of SQL, you can sort of apply that and just kind of learn the tweaks between different systems as you go. So this is called the CRUD. Database interactions are broken down into CRUD, and what that stands for is create, read, update, and delete. And for our purposes, what we really care about is the read. So I'm just going to focus on read, and I'm not going to worry about any of this other stuff because I've only got till 1. But and that's why I'm saying this is geared towards you guys. So this is what you care about the most. So let's talk about tables. Let's see what tables are really made up of. And so this is what we're commonly used to seeing: Excel spreadsheets with, we got a header across the top and some data and pretty common stuff. What's interesting is that we have these headers across the top here that we use to kind of get an idea of this is the data that's stored in this column. So we're really familiar with this idea of storing data in this format. Tables really aren't any different. Database tables are essentially that. This is a table. I called it people. Could be called, a variety, whatever you want to call it. But it consists of the exact same data that we were just looking at in that Excel spreadsheet. We have the unique ID, just like the spreadsheet had, and then we have all of our column names with their given data inside of it. Nothing weird here. So what's SQL? SQL stands for Structured Query Language, and it's a programming language for communicating with Relational Database Management Systems, or also known as RDBMS. And it's really, I guess I can just show you, that's SQL. And it's a big old nasty clump of SQL, but let's not get too hung up on that because we can do a ton of really useful stuff with just 4 lines. This is probably one of the most commonly used SQL structures, is these 4 lines. So let's look at that a little bit more closely. So I've kind of constructed this so that you can kind of follow. This box here represents this people table represents data that's stored on a SQL server somewhere that you want to get at. Our results here are going to be the results of a query that I'm going to put in this gray box over here, so that you're not confused about what is this and what is this. And so this we don't really see, but I'm showing you for comparison purposes. This sits in a SQL server, and we want to get at it. So let's look at our SQL query. Select star from people. This is broken down. The 2 main parts are select, and select is where you specify which column you want to pull in. It's the names of the columns. And in this case, I'm using star. Star is a wild card. It will give you everything. So whatever's in a table, give it to me. After that, we've got from, and from specifies the name of the table that you want to pull down. So really, really simple. None of this stuff is weird. So you're specifying what you want and where you want to get it from. And we can see here we've gotten the exact same thing. Give me everything from this table. So there's our results. So what if I want to do something a little bit different here? I want to get just name and gender. Very straightforward, just as you'd expect. Name and gender gives you name and gender. And we can do other cool stuff. We can add order to this, order by, and we specify the name of the column we want to order by. And by default, I believe, if we don't specify, it'll sort ascending order, but you can specify descending or whatever. It's pretty straightforward. And we can see that we've sorted our people in descending order, or sorry, gender. So we can also do filters. So the where statement allows you to do filtering. So now I've filtered, I only want the males from this table. So I've only received the males. None of this stuff is super complicated. It's very straightforward, and that's why I felt like we could really kind of go through this without knowing anything. We're going from 0. So let's do filter on blonde. We don't actually have to filter on things that we're pulling in. Like I was filtering on gender because we're pulling it down, but we can also filter on things that we're not actually pulling in, like hair color. None of that matters. We can add multiple filters. So the first filter you're going to add, you use a where, and then from there you just keep adding ands, and you can filter on this and this and this. And you'll see now we only have female blonde-haired people from our people table. So let's talk about functions. There's 2 types of functions that you can apply to your queries, scalar and aggregate. Let's take a look at some scalar functions here. And what scalar functions do is they take your results and turn them into something else. So in the case of uCase, it will take your result, and I'll show you examples of this. It'll take your result and make it uppercase or lowercase, or you can get the length or round a number. All of these different functions, you can say, I want this column and I want to apply this scalar function to it to change it in some way. And this is just an example. There's a whole bunch of scalar functions. And then we have our aggregate functions. And aggregate functions are a similar thing, but they will actually compress our results into a single result. So we've got average, count, last, sum. Sum's probably the easiest one. So I've got all of these different ages, and I want to see what's the if all these people were combined together, what's their total age? And so it'll sum up all the ages. If I want to get the average age of the people in my people table, and so on. So you can kind of see the difference. One modifies all of the results, and one compresses it into a grouped result, basically. So let's take a look at some of these in action. So I've got LCase, and so I mentioned some of the quirks between different implementations of SQL. I believe MySQL uses LCase. I believe Oracle uses upper, but these are kind of the quirks that you just you'll go and if you're not used to one and you're trying to convert something to uppercase and it's not working, just go and Google it real quick. It's real easy. But those are the little quirks that they have between syntax. But it's basically the same beast. So here I'm taking and I'm grabbing the gender and I want it in lowercase format. And I'm also something else that I haven't covered yet is you can actually add your own results into your or your own input into your results as well. So I've just added the string sum and I'm calling it as type. And I'll go right back to that. And then we have sum age, and so I'm just summing up. And I'm starting filtered down to one person. So we have one person, female, 22. So that's this person here. And I'll remove the filters, and you'll see how it changes. But before I do that, so the as on our select statement here on each of our columns. You can rename these columns to call them whatever you want. So I have name here. If you want, you could rename this so that it says first name or whatever. So it's to help you kind of organize your results. If I didn't have these as gender on there, I believe the column name would actually be called LCase bracket gender. So it just kind of keeps things clean. So that's why I do that. And then so that's how you add your own input. So let's go ahead and remove the filter and remove one of them, and we'll see that we're starting to sum up our females. So now we're only looking at females, and we're summing up both females. So let's go a little bit further, but before we do that, let's look at groups. So you, when you do aggregates, generally you want to group things. You want to group your table by some column. So let's take a look at what group by ID would look like. ID, by definition, is unique. And so grouping by ID would return the exact same thing because each of these is unique. So let's look at group by name. In this case, each of the names is unique, so it would still return the same thing, but not necessarily. You could have 2 Johns or 2 Janes or whatever, so you could group by, I want to see all my Johns. Same thing with gender. So now we've got male and female. We've got 2 categories, so we could group this down into gender. Same thing with age. We've got 2 groups. We could group by all 22-year-olds and all 46-year-olds and do something interesting with that. Lastly, we've got hair color, and we've got 3 groups. So we'd have 3 groups here, 3 different hair colors. So let's just look at our gender and age real quick and see what that would look like if we grouped it. And so I've kind of denoted there, that's what grouping and summing looks like in SQL. Pretty straightforward. And again, with average, same deal. We're grouping by gender, and we're getting the average. So let's look at the query of that. So now I'm grouping by gender, so I've got both my male and female, and I'm summing on age, so I'm getting the sum of ages for both male and female. And you can see where this scales out to be more interesting. If you've got a table with a bunch of different occupations, you can group by each occupation and get their average wage or something, a variety of different results. But you kind of get the idea. And so then we can do the same thing with average or a whole host of different aggregator functions. So let's talk about relational databases. This is my favorite part. So databases, like we said, are ideally designed to model the who, what, when, where, why of whatever you want to track. So in order to do that, generally we need more than one table. And so here's another kind of map of another database. This would be something like Facebook, although I'm sure Facebook's is a million times more complicated. But you can see we've got users and profiles and feeds and comments and photos and friends and all this stuff. So all of these are individual tables that relate to each other. So we've got this sort of mess of connections drawn all over the place between these tables to show how they relate to each other. So let's talk about those relationships. So table relationships, there's 3 types of table relationships. There's one-to-one, and here we've got that illustrated where every guy has one girlfriend and every girl has one boyfriend in this situation. Or we've got another situation called one-to-many. In this case, Hugh has many girlfriends and his girlfriends are dating Hugh. That's a one-to-many. Then we've got our many-to-many relationship where I'm not exactly sure what's going on, but we can see that this, a guy can have many girlfriends and a girl can have many guy friends. Vice versa. You get it. The internet's a cool place to find material for presentations. So let's take a look at what these look like in tables. So we've got a customer table here that's storing a variety of information, and let's say we need to store all this information, but we really are only using name and phone a majority of the time. As somebody who's designing a database, I may consider reorganizing this table into a one-to-one relationship. So what I might do is break that information out, give it its own table, and through customer ID, we have a one-to-one relationship. Every company has its address located in a separate table. And there's not a ton of use case for this, but there is use case for it. Most of it is speed performance. So if you're writing queries against a big table, but you're really only pulling a couple of pieces of information from it all the time, you can break it out into a one-to-one relationship, and you'll be able to query that table a lot faster. But it's still helpful to understand what a one-to-one relationship is. But and so this relationship is stored through what's called a primary and foreign key. Primary key is the unique ID in our customers table, which is then stored in our addresses table to maintain that relationship. So let's look at many-to-many now. And here's a situation that's probably more common, where we have customers that have multiple locations. So every company in this case has, or not every company, but a company can have multiple locations, but that location only has one company. So you don't have, sometimes you do, but generally for what we're talking about here, you're not going to have multiple companies in the same address. They'll have their own address. And we can see that through these relationships. And again, we're storing that relationship in a primary and foreign key. So let's look at many-to-many relationships. So Acme, in this case, we'll say that Acme has locations in both Pacific and Midwest territories. We'll call these sales territories. At the same time, Sage could also have have locations in the Pacific territory. So in this case, Pacific has two companies. So, and the same thing would go with Sage. We've got this many-to-many relationship. So let's look at a couple of ways we might store this to see how we definitely don't want to do that. What we could do is start storing these relationships in unique columns. So for every location, we'll have a column, and we'll store the ID of the territory in our customers table. But what we end up with is these empty cells. It's a big waste of time. And let's say Starbucks comes along, and now Starbucks is my customer, and they've got how many locations? And then I've got some mom and pop who has one location. Am I going to have a column for every single location to store that relationship? It just doesn't make sense, and it just makes me angry, so I'm going to light it on fire. Yeah, so this is what you do when you're making presentations to entertain yourself. Same thing here. We've got the same problem. It just doesn't make sense to give each territory or each customer its own column to track it. So let's get rid of that. What we really need is a third table. And this table will store relationships for these two other tables. And so now you can see we've got both of our relationships through this customer territories table. So we've got Acme, who has both Pacific and Midwest, and it's stored through these two records here. And at the same time, we've got Sage, who has all three of those territories stored through this table here, and we have those the IDs of both of those tables stored here. So let's see some joins. And joins are kind of what we call joining multiple tables together. So now I've got my customers and my addresses, and we want to look at a one-to-one relationship. Oops, sorry, looked too far ahead. Go back. There we go. Okay, so here we've got, for starters, just our regular SQL query. We just want to get all three columns from our customers table. No big deal, nothing weird here. Now we want to see what happens if we want to add a zip code, the zip code as well. This is how we would join it in. And sorry it's so low. I should have bumped everything up. So what we have is join addresses on customer ID and ID. So where customer ID equals ID, so we've got customer ID in the addresses table, and we've got ID in the customer table. And so we're saying where those two are equal, that's our relationship. And for Acme, their ID is 1. Our customer ID is 1 in our addresses table. So we can relate those two through that relationship. Does that make sense? Can I rephrase that for anybody? Okay, so I'm going to move on a little bit. Let's take a look at a one-to-many join. So now we've got our multiple addresses again, and we're going to do basically the same thing. We're going to join addresses on a customer, and I'm just pulling down Acme in this case. So I'm doing a where on the name Acme and getting back my both my records. And you can see actually that it's duplicated Acme because we have multiple zip codes. It's going to duplicate Acme to accommodate for both of those results. Does that make sense? Okay. And actually, one thing that I didn't mention is that the notation's actually changed a little bit. And this is because of the fact that we have multiple tables that can have the same name. ID, for instance, it exists in both tables. So what we need to do is specify which ID we actually want to pull in. Do we want to pull in the ID from customers or addresses? So I'm just like we used as before to rename a column name to something else, we can do the same thing with tables. And so since I'm short on space here and trying to keep everything nice and big for you, I essentially renamed customers, the customers table there, to C, and I renamed the addresses table to A. And so you can see everything that's C dot is coming from the customers table, and everything that's A dot is coming from the addresses table. So if you're ever, you don't necessarily have to if it's unique. So like there's no name in our addresses table, but it's generally a good idea if you have data coming from every which way. It's just really nice, even if you don't have to do that across your entire query, because it just keeps you from doing weird mistakes that you might do otherwise. And naming convention here is again subjective, but I'm shortening it to just one letter just to keep it really short and sweet for us so that it doesn't get too big and messy. So let's continue on. And let's take a look at our many-to-many relationship. So now I've got, I'm going to join these one at a time. So I've joined the customers table to our customer territories table. And that's just join customer territories. And again, I'm renaming that just to CT on ct.customer_ID, where customer ID equals the ID in the customers table. And you can see I pulled it in here. So let's join in our third table. So we want to pull in the territory. And again, I'm leaving territory ID in here. Generally, don't care about those IDs when you're doing queries. I'm just showing it for illustration purposes. You don't have to have any of that stuff. Purely for illustration. So we can see now on my select, I've got my my columns for my customer table. I've got my column from my customer territories table, and I've got my customer from my territory table in my select. And then I've got two joins now. Join customer territories on customer ID equals ID, and then join territories on my customer territory ID. So where my customer territory, oh my God. Yeah. So where these IDs equal this ID, make those a join. Join these records together. That's essentially what I'm doing. So you can kind of see how we're joining these together through this middle table. And if I can re-explain that, I'll try.
So when you're joining them, does it just create a whole new table and you're renaming it after the equal sign? So the new table can see create ID? Or?
So I'm just renaming these individually. So this is basically called T. This is called, imagine that they were called these originally. This is called T, this is called CT, and that's called C.
So what does the equal sign mean?
So equals is saying, so let's look at the first join here, where we've got customer ID. Customer ID is right here. So we're saying where customer ID equals ID in our customer table.
Oh, okay. All right.
So we've got our ID here, and we can say 2's here, 2's here, this one and these ones are all related based on that ID. And again, same thing with Acme, where we've got the customer ID is this one here. And again, with our territories, we've got this ID 4 relates to this territory, and so on.
And so you get this table as in the results column, but how do you
So
name that?
exactly, this is the results that you get because essentially you can imagine that these are all in one table once you've done those joins down there at the bottom. Does that make sense?
Yeah.
So once you've done the joins, that's the hard work. The easy work is just saying, give me that column, give me that column, give me that column. I can pretend these are all in one giant table. And we see they're all joined together. So, where do we go from here? I'm actually doing all right on time, but I was concerned that I wouldn't have enough to actually get you someplace useful. Because the idea is that, okay, I've shown you this, but how do you go and play around with it yourself? And I did a bunch of research and tried to find something, setting up your own SQL database, populating that database with tables and records is a pain. And it's probably more than what you'd need to know more about SQL than what I've shown you here. What I've shown you is what you need to know, and it'd be nice if there was a nice database somewhere where that already has data that you guys can go and just write queries against and see what the results look like. So after looking around a bunch, really the best result that I've found is to go and create, Heroku offers these cloud databases. So I've gone and set up a database that essentially sits on the internet, and you guys can download an application that lets you write commands against my cloud database and get results back without having to do any setup. Unfortunately, that's the only way that I could figure out how to do it. There's something called SQL Fiddle, and it's kind of a web interface where you can write SQL, but it doesn't come populated with anything. So you need to know enough SQL to create all the tables and all the records in those tables to actually write queries against. So you kind of see where my dilemma is here. Fortunately, Heroku has a nice cloud option that is pretty straightforward to set up. And I actually created a video last night in the middle of the night because that's the only time I've had to do it. But I have a video. If you go to this website, that's the post. There's a video at the bottom with connection instructions, and I actually walk you through downloading an application that will connect to, this is using Postgres, and then you can write queries, and I think I have all the tables that I used in this lecture basically duplicated in this Heroku database. So that is pretty much how you get from 0 to what I would consider roughly intermediate SQL queries. Can I answer any questions? Yeah?
So we know how to group our data and get what data we want and how we want it structured. What's the next step as far as how you want to take it and put it into a statistical package or something like that?
So once you've gotten the results back the way that you want it, you can export it generally as a lot of them will export as an XML, or a CSV or a XLS spreadsheet file, and probably several other formats as well. I generally just export them out as a CSV or an XLS, depending on what I'm trying to do with it. Yeah?
Say if you want to pick, you want to group out, say all the ages that start with 20. Instead of picking like a certain age, how do you pick out, say like all the names that start with P?
Okay. I've got a little bit of time, so I can show you that.
Is it easy or is there?
No, it is. So the syntax, I can tell you, it's there's something called like, and so you can say instead of equals, you say like, and then so if you wanted to see if it starts with P, you're saying, so say the name starts with P. You want all the P names, so you could say name, instead of saying equals, you'll say name like. And then in single quotes, you'll say P and then percent. And percent is a wild card to say anything that starts with P. So P, anything after that. Or you could do anything that contains P. So percent P percent. And you'll get any record with or any name that has P in it. Or again, if you wanted anything that ends with P, percent P. And so there's lots of it's really straightforward to kind of carry this out into tons of other things that you can do. I showed you that giant SQL query. I have like SQL queries that are just make me sad to look at because they're just so big, but the way that the data is structured, you have to get it how you have to get it. If I have to go to this table and grab some records here and then go to this table and grab some records here and then stack them on top of each other, to get my whole data set, I'll do that. And a lot of times I'll have to do a join across 3 tables, get those records, do a join across several other tables, get those records, and stack those on top of each other. It just kind of adds up to large SQL queries, but it's all based off of these very simple concepts that you just stack on top of each other. Yeah?
Look at 2 databases where one had observations by state, and the state was a 2-letter AL for Alabama and so on. In the other database, the states were spelled out Alaska for Alabama.
Okay, so, yeah.
Would you be able to merge those 2 by state without having to rename one?
So what you would need to do is something called, I believe it's called encode. And what you would basically do is remap one to the other. So you'd have to tell, SQL doesn't know one name format from another. So there's something called encode where you can basically say this is this, and this is this, and this is this, and once it knows that specification, it will map them for you. And that's using a command called encode. Another option is to join in another table that has that same information, and you could join them that way. So you could say where this table's state equals this table, your basically your interpretation table, where CA equals CA here, and then another column has California written out, and you join that to your third table where California equals California. And that would join them together that way. And depending on, if you can write your tables, then that's cool. If not, you can use encode, and they do basically the same thing. Yeah?
So is there a way, I'm sure there is, but do you know how you continue your SQL data? Because it's on a server, right? So you don't want to, if you want to access something, you don't want to do it every day, but you want it done every day.
Yeah, so we do that. We do that all the time, and we set up these queries into jobs that are executed on some interval. So I have tons of jobs that run every morning and send out reports with the query. So I'll write query and set up a job that says, okay, send the results of that query to every one of our salespeople so that they can see how they did yesterday or last month or last whatever for every quarter. You can do them. So say you have an application that needs to be continuously feeding data, it will continuously ping that database with that query, get the results back, and perform whatever analysis that program is doing. Like if you have some program that, I've told this story a few times to some people, but I have a friend that writes queries against the database of information, pulls that information in, analyzes it, and then executes stock trades. And this is instantaneously. So there's something that's constantly feeding a database, whether it's point of sale or some other source, constantly feeding in, and then you've got something on the other side that's constantly pinging it for information. But it generally you can write a query, and it'll use that query over and over and over to do whatever it's doing. Yeah.
You said you were self-taught on all of this. Did you have a little book like
Yes. So I have a couple of book recommendations. O'Reilly, generally, I've found to be the best publisher of tech books in general, and they offer a book called Head First, which I think would be really good for you guys. They start, again, way at the bottom. They don't assume you know anything. Not that you guys need to, but it's good to have absolutely nothing and say, we're starting from absolute zero, I'm going to teach you everything. So they have a book called Head First SQL, and I highly recommend it. It's a great book. And then there is another book that I wanted to recommend. And I forget the name of it. It's also by O'Reilly. And I don't recall the name, so I'll get you the name. But if you just go to O'Reilly and search SQL, they've got probably half a dozen different SQL books written by different authors, and they're just great. They're really good at collecting great authors. So, and I think they're local around here. Are they? Yeah. So, can't go wrong with O'Reilly. I like them a lot. The other option is, and I use this a lot, is the internet. If I had to point you to a website, I would probably point you to W3C or W3C School. W3C School, they're kind of old and clunky and not super up to date, but they've done a pretty decent job of just saying, here is all of the functions, and here's what it is, what it does, and maybe a before and after. This is what the query did. Here's the results. So they do a pretty good job of formatting the results, but they're just kind of antiquated, I guess. But I don't have one source that I could recommend better than that. Maybe someone else does, but I don't.
This is really good.
Yeah. Okay. Great. I appreciate that.